Often, when globe earthers hear that the law of perspective is the reason that ships disappear beyond the horizon, as well as the reason that the sun and moon rise and set in the sky, their next question is why, then, do the sun and moon appear to get bigger near the horizon? Understandably, a long row of street lamps appears to rise in height until reaching overhead and then sets on the horizon, similar to the sun and moon. But unlike the sun and moon, the lampposts, boats, and most other things claimed to disappear due to perspective also shrink in size as they recede from the observer. So why, if the sun and moon rise and set due to the law of perspective, do they also not appear to shrink as they approach the horizon? To begin with, if you view enough time-lapse footage of sunsets and moonsets, you will find that sometimes they do actually clearly shrink as they approach the horizon. Sunsets and moonsets filmed in the desert or other arid areas will often show a large sun and moon overhead steadily shrinking as they recede from the camera. In many cases and places, however, the opposite occurs, and the sun and moon appear to grow in size as they approach the horizon. So what is happening then? When any kind of light shines through a dense medium, it appears larger and creates a greater glare at a given distance than when it is seen through a lighter medium. This effect is more pronounced if the medium holds aqueous particles or vapor in solution, such as in a damp or foggy atmosphere. For example, if you stand a few yards away from a street lamp and notice the size of the light, then walk and view the same light from a few hundred yards away, you will notice the light now appears considerably larger. Snapshots of cityscapes at night, taken from altitude, also show this phenomenon. Distant city lights near the horizon appear much bigger and brighter than those near the camera, even though they are further away. This can be observed to a greater or lesser degree at all times, but is most intense when the air is moist and vapory. Obviously, at sunrise and sunset, the sun's light must shine through a greater length of atmosphere than at midday, and in addition to this, the air nearest the earth is both more dense and holds more watery particles in solution than the higher strata through which the sun shines at noon, resulting in a light that is magnified as well as modified in color. eNature.com writes that, quote, "The moon's warm color, when seen at lower angles, is caused by the relatively larger amount of atmosphere through which one is observing it as compared to when the moon is right overhead. This additional atmosphere scatters the bluish component of the light of the moon, making the low-lying moon appear redder to the observer's eyes. If you look later when the moon is higher above the horizon, you will see it appears much whiter than earlier in the evening." Other contributing factors to consider include wavelength, diffraction, air pressure, air temperature, atmospheric lensing, width of aperture, altitude, humidity, and clarity, all of which affect the net result. The amount to which the sun or moon will be magnified due to the above reasons, and shrink due to the law of perspective, will depend on the confluence of all forces involved. In other words, as the sun and moon set on the horizon, from an observer's perspective on Earth, they will simultaneously get bigger due to the many reasons given above, while getting smaller due to the law of perspective, and the net result is what you see.